Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on gravity and gravitational field from March 2021, paper 4, variant 2. I said this is a typical type of question because this type of questions are very common in past papers. In today's class, we are talking about March 2021, paper 4-2. Time for this exam is 2 hours and you need to answer all questions in this paper, and the total mark for this paper is 100. On the second page of your exam paper, you can find values of some common constants. And in paper 4, you will need some of them to do some calculations. So if you need value of any constant, you can come back to page 2 and you can find the value of constants. On third page of exam paper, some important formulae are also given. The first formula for A2 physics is about gravitational potential, very common one. Most of the time you will need this one for question number 1. And the next formula is from thermal physics, and the next two formulae, these are from simple harmonic motion, and the next one is from electric field, very common one. You need this one for some calculations. And next three formulae, these are from capacitance, very common one. You will also need for some calculation if there is any question about capacitor. And the next one is about Hall voltage, typical type of formula, and in many past papers you will see questions based on this formula. And next one is from alternating current from AC, very common one. And the next two formulae are from nuclear physics. So you will need them for some calculations most of the time in your exam. So let me highlight this formula. It's very important one. Let me explain you this one a little bit. Here, for example, the x you can replace with n with number of nuclei. So this you can write down. This will be equal to n naught times e to the power of negative lambda t. X you can also replace with activity. So we can also say activity at any given time. This will be equal to initial activity times e to the power of negative lambda t. So mean x you can replace with n, or you can replace x with a. For part A, question is asking us to state Newton's law of gravitation, and this question has 2 marks, and this is a typical type of question. It simply means that almost every year they will ask you to state Newton's law of gravitation. So let's try to understand what exactly Newton's law of gravitation is. Imagine that we have one mass, this is m1, and we have another mass, let's say this is m2, and the distance between centers of these two masses, let's say the distance is equal to d. So Newton's law of gravitation simply tells us the force of attraction between these two masses is directly proportional to the product of these masses, and the force of attraction, or you can say the gravitational force, this is inversely proportional to the square of separation, or simply you can say square of distance between these masses. We can say this is 1 and this is 2. Now if we combine 1 and 2, we can also write down F is directly proportional to m1 times m2 divided by d square, means inversely proportional to d square. We can also write down this one in equation form. We can write down F is equal to capital G m1 m2 divided by d square, and G is the universal gravitational constant, and its value is 6.67 times 10 to negative 11 Newton meter square per kg square. You can see this value is very small. So force of attraction is significant for heavy masses. That's the reason you don't feel force of attraction between you and your friends or your neighbor. So this is significant for heavy masses. Now let's try to write down the answer for this. In order to answer this question has 2 marks, so you have to mention these 2 points. So this can be point 1 and this can be second point. This is how you can write down your answer. If you have mentioned in your answer gravitational force between 2 point masses, later I will explain you this one why we need to say 2 point masses, mean point masses, is directly proportional to the product of the masses, you will get 1 mark, and that will be B mark. And the second mark you will get if you have mentioned inversely proportional to the square of the separation. So this is second B mark. So this is how you will get 2 marks. The second point we need to understand about gravitational force is that the force between two masses, it does not depend on medium. So simply I will say the force does not depend on medium. Does not depend on medium, or simply you can say the force is independent of medium. So in this case I'm writing it does not depend on medium. So very important point. So it simply means that if we have two masses, let's say we have these two masses, they are in the air, so there is a force between them. Now if we take and we place these two masses inside water, so the force of attraction between them will be the same if we keep the distance between these two masses same. So that's the reason the force of attraction between these two objects is independent of medium. And the next thing we also need to understand is that the force F1 means the force on 1 by 2 we can write down in vector form. This will be equal to the force on 2 by 1 but in opposite direction. So negative sign is telling you that this is in opposite direction. So this is also very important point we need to understand. Newton's law of gravitation, this is only valid for point masses. So this is only valid for point masses. So the size of the object has to be very small. So this is only valid for point masses. So the point masses simply means that one thing you can say the size of object is very small. So you can say size of object is very small. So this is one thing is telling you point masses. Size of object is very small. So we can treat as a point mass. You can also treat an object means two objects as a point masses if the distance between the masses is much greater than the size of the objects. For example, we calculate the force of attraction between sun and our planet. So this is our planet Earth. So the distance between these two is much greater than the size of them. So we can treat them as a point masses. So that's the reason we use here point masses. Sometimes this question has 3 marks and 1 mark only will be for point masses. If you will mention point masses, you will get the 3rd mark, otherwise you will not get. So when you define Newton's law of gravitation, you have to be clear. It is the gravitational force between two masses that is directly proportional to the product of masses and inversely proportional to the square of distance between them. I hope it is now very clear to you. Let's move on to next part. For part B, the graph between t square and r cube is given to us, and we will be using this graph to answer part B. So let's move on to next page and try to answer next question. For part B, question is asking us to determine the mass capital M, means question is asking us to calculate capital M, but the graph between t square and r cube is given, and this graph is a straight line. So simply we can compare this one with straight line equation. We can simply say y is equal to mx plus c, but c in this case is equal to 0 because this is passing through origin, so there is no y-intercept. Now if we compare here, so this is over y and this one is over x, and the gradient means the m from here will be equal to 4 pi squared divided by gravitational constant times capital M. But we need to calculate m, so simply we can rearrange. We can write down 4 pi square divided by g times the gradient, means the gradient of the graph. That's all what we need to do. Simply we can calculate the gradient of this line and we can plug in here and we can calculate value of mass. I have done this calculation already, so let me show you how I have done. So if you look at this one, first of all I have taken these 2 points, mean this point and this point. I have calculated gradient of the graph and this is our answer. Now I have plug in values of the gradient. So this is value of the gradient, but you can see this one, this is in years, so I have converted year into seconds. So this is 365 days, 1 day has 24 hours and 1 hour has 3600 seconds, and this is over final answer. Part C question is telling us that a rock of mass small m is also in orbit around a star in B. The radius of the orbit is r. Explain why the gravitational potential energy of the rock is negative. This is very common question, so simply we can understand. Imagine that we have star here. So this one is the star. So this is a big object, heavy object, and let's say in this orbit the rock means is orbiting, so this one is the rock. So simply we can imagine that this one is the rock. Now we need to understand is that if we go to the infinity, very far away from the star, at this point we take gravitational potential energy at infinity, this is equal to 0, and anywhere between the star and the infinity, gravitational potential energy, I'm writing this as GPE, this is taken as negative. Why this is negative? Because here potential energy is the maximum. So anywhere between the star and infinity, gravitational potential energy is less than gravitational potential energy at infinity. So that's the reason this is taken as negative. Another way to understand this one is, let's say we have this is ground. If we raise this mass, for example, we place this mass on the ground. If we raise this one, the gravitational potential energy of this object will increase. Now imagine that we raise this object to this point, and now we lower this one, means we bring this one down. So the gravitational potential energy of this one will decrease. But in this case, we are assuming that the maximum gravitational potential energy means is at infinity, and that we are taken is equal to 0. So between the star and the infinity, gravitational potential energy has to be lower than GPE at infinity. So the only possibility, it has to be negative. And other way to understand this one is that if you take any object away, I mean if we take this rock away from the star, the gravitational potential energy will go on increasing. As simply in this case, if we raise this object, so the gravitational potential energy of this object will increase. And other way to understand this one is that when you raise this one, we do work against gravity, and that work done becomes GPE of the object. But if we lower this one, the work is done by gravity, so the energy got out of the system, so the gravitational potential energy of this object decreases. So simply what I'm saying is that if we move this object this way, the GPE of this rock will decrease. So simply we can say GPE will decrease. But if we move this rock away from the star, GPE, gravitational potential energy of this rock will increase, because if we move away, we will do work against gravity, and that becomes the GPE of this object. But if we move this way, in this way work done is done by gravity, so it means energy got out of the system, so the GPE of this rock will decrease, and that will be more and more negative. So let's try to write down our answer now. I hope you got some idea. Now let's try to write down our answer. So this is how you can write down your answer. The first point you have to mention is that GPE is, or simply you can say gravitational potential is defined as 0 at infinity, and GPE is also 0 at infinity. Since gravity is always an attractive force, object in a gravitational field will always be attracted inwards. Hence work is done by gravity, work got out, causing rock to lose GPE. So when it is pulled from infinity, means if we pull object this way, work is done by gravity and GPE will decrease. So gravitational potential energy of the rock is always negative, because the maximum is 0 and the lower than that one is negative. So between star and infinity, GPE is always negative. This question has 3 marks. If you have mentioned that gravitational potential energy is defined 0 at infinity, 20, you will get 1 mark, and this is B mark. And the second B mark you will get, if you have mentioned gravity is always an attractive force, you will get the second B mark, so this is second B mark. And the third mark you will get, if you have written work is done by gravity, work got out causing rock to lose GPE, so you will get the third B mark. So this is how marks will be awarded. Now let's move on to next part. The second part, C2, is asking us, show that the kinetic energy of the rock is given by EK is equal to capital G, capital M, small m over 2r. So in this case, this is our star and the mass of the star is capital M. So simply we can say this is mass of the star and the rock is here orbiting around the star and the mass of the rock is M. Now we need to show that kinetic energy of the rock is given by this. I have already done so. Let me look at my answer and explain you with the help of my answer. Now you can see in this case I have written already gravitational force provides the centripetal force, meaning this rock is orbiting around the star, so there is centripetal force acting on this and that centripetal force is due to gravity. So this is a very good point if you write down here. Now in this case what we have done next, gravitational force is providing the centripetal force, so this is our gravitational force and this one is the centripetal force. So R we can cancel on both sides because this is common, and then we got this one here. So you can see G capital M small m over 2R. So we have divided by 2 on both sides. So this is 2 here and this is 2 here. And this is kinetic energy now. EK, this is equal to capital G capital M small m divided by 2. This question has 2 marks. The first mark is M mark. You will get this first mark M mark if you have equated these two forces. And the second mark is answer mark. You will get this answer mark if you got the right answer. So this mark is very important. If you simply write down this one, of course you will not get any mark. So you have to show the process, means you have to show your working to get 2 marks. For the last part, question is asking us to use the expression in second part to derive an expression for the total energy of the rock. First of all, let's try to understand what is total energy of the rock. So this is our star, so simply you can imagine that this one is the star and the mass of this one is capital M, and the rock is here, its mass is M, and this rock is orbiting around this star, so it is orbiting around this star like this. Now this rock, it has 2 kinds of energy. The one is the kinetic energy because it has speed, it is orbiting around this one, and the second energy of this one is GPE, gravitational potential energy, that is due to its position around this star. So this, it has 2 kinds of energies, kinetic and GPE, gravitational potential energy. Now the total energy, simply we can say that in this case E total means the total energy of this rock is simply equal to gravitational potential energy plus the kinetic energy of the rock. Now simply we have to add these two together. Gravitational potential energy of the rock, this is capital G capital M small m divided by R, and R is the distance from the center of the star to the center of this mass. And kinetic energy we have already calculated, that was G capital M small m divided by 2R. Now we simply have to simplify this one. In this case we can take LCM. LCM is 2R, so this one has to be multiplied by 2 because if you divide this one by R you will get 2. So this is 2 capital G capital M small m plus we have G capital M and small m. So our final answer in this case is capital G capital M small m divided by 2R. So this is total energy of the rock. Now maybe some students are not clear why we're using negative sign here, because the rock is here, it is between star and infinity. At infinity we have already discussed GPE is equal to 0. So that's the reason we have to use negative sign here. So this is very important one. You have to use negative sign here. So our final answer for this one one is this. So this is total energy of the rock. This question has 2 marks. The first mark you will get if you have written total energy is equal to EP plus EK, means is equal to GPE and kinetic energy. You will get first mark, and this is C mark. And the second mark is answer mark. If you got the right answer, you will get second mark. This is how marks will be awarded for this part. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on thermal physics from March 2021, paper 4, variant 2. For part A1, question is asking us to calculate the number of molecules in the gas. But for this question, temperature of the gas is given, so simply we can say this is temperature. And the pressure of the gas is given, simply we can say this is P. And volume of the gas is given, so simply we can say this is V. Now we need to calculate number of molecules in the gas. So the first thing you need to consider is that PV is equal to nRT. In this equation, you don't see number of molecules. That N is here. N is the number of moles. So first thing we can calculate is number of moles. So we can calculate number of moles will be equal to PV divided by RT. And T has to be in Kelvin. So you have to be very clear about that. T must be in Kelvin. So it has to be in Kelvin. So let me write on here. It has to be in Kelvins. If we can get number of moles, when we have number of moles, then we can calculate number of molecules. So this will be our first step. In the second step, you can write down number of molecules divided by Avogadro's number. This is equal to number of moles. So from here, we can calculate number of molecules. This will be equal to number of moles times Avogadro's number. So you will get your final answer. Means if you follow these steps, you have to do this one in 2 steps if you use this method. But now we need to understand how we can do the same question just in 1 step. So for that purpose, you need to understand PV is also equal to NKT. K is the Boltzmann constant, N is the number of molecules. So here, if you use this one, so you can say PV divided by K times T. Temperature has to be in Kelvin, so you can calculate number of molecules directly. Now let me explain to you how you can convert this one into this form. So from here, you need to understand N. For example, N you can replace with capital N divided by Na. So N we can replace from here. So I'll be writing here. So this is PV. And so N you can replace with number of molecules divided by Avogadro's number and times RT. From here, we can also understand R over Na. This is equal to N other constant. So we can write down now PV. This is equal to N and R divided by Avogadro's number means gas constant. If you divide by Na, this is equal to Boltzmann constant. So simply we can write down here PV is equal to NKT. So this is how you can convert this equation into this one. Now simply we have the formula, we have all quantities, the values are given, simply plug in and you can find the answer. This is how you can do the calculations. This is important point, you have to be careful. Temperature has to be in Kelvin and rest is just simple calculation, and this answer has to be in 2SF because the least number of SF we have in our raw data 2SF. So our final answer also should have 2SF. So this is how you can write down your final answer. This question has 2 marks. The first mark is if you follow this one, the first mark will be for this step. If you have written N is equal to PV over RT, and the second mark is if you have done this step and you got the right answer, so you will get answer mark. So this has 2 marks. But in this case, if you have used this formula, this will give you 1 mark, and the final mark is answer mark. You will get answer mark if you got the right answer. For the second part, question is asking us to determine the root mean square speed of the gas molecules, mean RMS speed of the gas molecules. But the mass of one molecule of the gas is given, that is equal to 40 U. So question is asking us about speed of the gas molecule. So it means that we need to consider kinetic energy of gas molecules. So we will start from here. The average translational kinetic energy of gas molecules is equal to 1/2 m times mean square speed. So this is mean square speed. This is how you need to write down. And this is equal to 3 by 2 kT. 3 by 2 kT. And K is a Boltzmann constant, and temperature has to be in kelvins. Very important. Temperature you have to use in kelvins. We need to calculate mean square speed. So simply first thing we can do is we can cancel 1 by 2 here. We can cancel with this. So now if we rearrange this one, we can write down mean square speed. This will be equal to 3 times kT divided by m. Means we're just dividing by m on both sides. Now we need root mean square speed. So it simply means that we have to take the root on both sides. So we will take root on this side, and we also have to take root on other side as well. Mean square root. We will take root on this side. So this speed now, this is CRMS, means root mean square speed. Now simply we need to plug in values and we can calculate RMS speed. Now you can pause the video and you can do calculations first by yourself, and then you can come back and you can compare your working with my working, and also you can compare your answer with my answer. So take some time and do calculations first by yourself. I hope you have done calculations. Now look at my answer now. In this question you can see here what we have done is that simply we have plug in values. So this is the value of the Boltzmann constant, and this is the temperature in kelvins. So you have to use temperature in kelvins, and this is 40 U. 40 U is given, but 1 U is equal to this one. So you have to convert this one into kgs, not in U. So that's the reason we have to multiply with this one. And this is our final answer. This has 3 SF. So we can write down in this form, we can write down this is 4.3 times 10 to 2. So means it has 2 SF. So this is our final answer. This question has 2 marks. You will get the first mark if you have used the right formula, and this is C mark. And the final mark is answer mark. You will get the final mark if you got the right answer. This is how these 2 marks will be awarded. For part B, it is given to us the temperature of the gas increased by 84 degrees Celsius. Increased by. So it simply means that the final temperature, this is equal to initial temperature plus 84 degrees Celsius. If it was written here increase to, then simply you can say the final temperature will be equal to 84 degrees Celsius. So you need to be very clear what is meant by increased by and what is meant by increased to. So this is kind of common mistake made by many students. So you have to be very clear about the language of the question. Now question is asking us to calculate the ratio between new RMS speed of molecules to original RMS speed of molecules. Means you have to divide new RMS speed by original RMS speed of molecules. Now temperature is higher. So for this purpose, simply you have to start from here. So C RMS, we have already derived this formula. This is equal to 3 kT divided by m. So this is 3 kT divided by m. Now from here you can see this is T here. We can write down this one in this form. We can say this is 3K divided by m. You can simply write down here this is root of T. We can divide by root of temperature on this side. So we also have to divide by root of temperature on left side. And this one we can simply cancel. So simply from here you can say C RMS means root means square speed of molecules divided by temperature in Kelvin. This is equal to 3K divided by m, the mass of one molecule. If you look at this side, you can see 3 is a constant, K is a constant. This is Boltzmann constant, and m is mass of molecules, and that is also constant. This is mass of one molecule. So simply we can say this is equal to some constant. The ratio between these two, this is equal to constant. So if temperature change, it means C RMS will change. So simply we can say that C RMS new divided by the T new, the root of this one, this also will be equal to constant, and these two constants, they will be same. So from here we can write down C RMS new divided by the root of T. This will be equal to CRMS original. I can simply say this is original, and this is new temperature. We can say this is new temperature divided by this is over initial temperature. So we can say this is original temperature. Now simply we need to rearrange them and we can find our final answer. So if we rearrange this one, so we will get here CRMS new divided by this one, so we can say CRMS original. This one will be equal to the temperature T new, so this is cross multiply, so this is T new divided by T original. So this is original mean initial temperature. Now simply we have to divide these two and we can get our final answer. So the new temperature is 21 plus 84. It has to be in Kelvin, so this is how you can convert into Kelvin. Divided by initial temperature, that was 21 degrees Celsius. We have to add 273 to convert into Kelvins. Now if we do this calculation, our final answer, you can try first by yourself, but if you have done in the right way, your final answer will be equal to this. So we can write down our final answer is equal to 1.1 up to 2 SF. So simply we can write down up to 2 SF. So this is our final answer and this is how you can do. I have explained in detail, but in exam you can do quickly. You can skip these points. You can quickly go to this one. This question has 2 marks. The first mark you will get if you have written this relationship, means you have written in this form, so simply we can say you will get C1 mark, and the final mark is the answer mark. If you have got right answer, you will get the second mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on thermal physics from March 2021, paper 4.2. In this question, we will explain why the specific latent heat of vaporization is much greater than the specific latent heat of fusion for the same substance. We will also answer questions based on specific heat capacity. For part A, we need to use simple kinetic model of matter and we need to describe the structure of solid. So this is kind of very basic question. So we have to write down some points about structure of a solid using simple kinetic model. The first point we can mention about structure of solid is particles in a solid, they are closely paired together. And the second one we can say about the vibrations, means the particles in solid, they vibrate about fixed positions. They do not change their position. They do not change their positions. It simply means that the shape of a solid is fixed. We can also mention about intermolecular forces. Intermolecular forces among solid particles are much stronger than intermolecular forces in liquids and also much stronger than intermolecular forces among gas molecules. So these points, if we write, we will get 2 marks. Now let me show you how you can write down a proper answer. So this is how you can write down your answers. You can see in this answer I have mentioned particles in a solid, they are closely packed in lattice structure. Particles can vibrate about fixed positions, but they do not change their positions relative to each other. And also I have mentioned intermolecular forces among solid particles are much stronger than intermolecular forces among liquid and among gas molecules. For part B, it is given to us the specific latent heat of vaporization is much greater than the specific latent heat of fusion for the same substance. Same substance, let's imagine that we are talking about water. So if you look at specific latent heat of vaporization of water, it is much greater than the specific latent heat of fusion of water. So this is what question is telling us, means for the same substance, any substance you can take. Next thing, question is asking us to explain this in terms of the spacing of molecules. So first of all, let's try to understand what is specific latent heat of fusion. It simply means that when solid change into liquid, if we have 1 kg of solid, it changes into 1 kg of liquid. at the same temperature, means temperature does not change in this process. So the amount of heat we supply, that is called specific latent heat of fusion. Now we also need to look at the separation between molecules. Molecules in solid, they are closely packed, almost closely packed, little space among molecules. It means the potential energy of the molecules increases a little, not a lot. We can say little bit potential energy of the molecules increases. And to increase the potential energy of the molecules, the amount we supply, amount of heat we supply, that is equal to increase in potential energy of the molecules, because in this case temperature does not change. So it means in this case the Q we need to supply, that has to be small, little. So that's the reason specific latent heat of fusion is very small. Now if you look at latent heat of vaporization, we can also simply understand in this case when liquid changes into gas. In liquid, the molecules are close together, but when liquid change into gas, molecules are far apart from each other. So it means in this case temperature does not change, kinetic energy of the molecules does not change, but the potential energy of the molecules increases a lot. So if the potential energy of the molecules increases a lot, it means Q supplied has to be a lot. So that's the reason the specific latent heat of vaporization is much greater than the specific latent heat of fusion. So let me explain to you how you can write down your answer. This is how you can write down your final answer. So you can see during the boiling process, means during vaporization, increase in molecular spacing among molecules is much greater than during the melting process. So that's the reason more work need to be done, or more energy need to be supplied when the liquid is changing into gas. So this is how you can answer. If you write down this point, you will get 1 mark, and that is B mark, meaning it has to be in your answer. For part C, the graph between temperature and time is given to us. Now if you look at this graph, you can see initially from here, you see the temperature is rising with time, but after that temperature is not changing. So this is simply telling us this is specific latent heat of fusion, means the melting is taking place here. So we can simply write down here the substance is melting. So this is melting process. So substance is melting here. So in this time interval, the amount of energy we will supply, that will be equal to specific latent heat of fusion. And then next we can see the temperature is again starts rising. So the temperature is rising. So it means that in this case, the amount of energy we have to supply, that will be equal to specific heat capacity. So this will be equal to specific heat capacity. Simply we can write down specific heat capacity. If we are talking about 1 kg of substance, if the mass of the substance is 1 kg, the amount of energy supplied between this point and this point, or you can say in this time interval, that will be equal to specific heat capacity. Now if you look at this, now this is again horizontal line. So what is happening here? In this case, the phase is changing now. So here the substance was melting, here phase is again changing. So in this case, substance is boiling now. So it simply means that the liquid is changing into gas. So simply we can say phase is changing, means the liquid is changing into gas. When the phase is changing, kinetic energy does not change, because temperature of substance does not change. So now the phase is changing, simply we will say potential energy of the molecules is increasing, and the separation among molecules is increasing, because the potential energy of the molecules increases. And this point we have already discussed in the previous part. When something boils, amount of energy supplied is greater than the amount of energy supplied when something is melting, because in this case molecules, the separation among molecules is much greater than the separation among molecules when something changes from solid into liquid. So that's the reason we have mentioned specific latent heat of vaporization is much greater than specific latent heat of fusion. We will need this graph to answer next questions. So let's move on to next one. For part C, one question is simply asking us to determine the temperature at which the substance melts. We have already discussed substance is melting here, means the solid is changing into liquid. Now simply we need to write down this temperature, and this is negative 100 degrees Celsius. So simply we have to write down this one. For the second part, power of the heater is given and power is equal to 150 watts. Question is asking us to use data from figure 3.1, and this is figure 3.1. So simply we can write down this is figure 3.1. We need to calculate in kilojoules per kg the specific latent heat of vaporization of the substance. Means we have to calculate L. L is the specific latent heat of vaporization. Now simple way to start this question is we can simply say Q supplied, means the amount of thermal energy supplied. This is equal to latent heat of vaporization plus Q lost, means the heat loss. But in this question it is given to us our apparatus is perfectly insulated, so it means that there is no heat loss. So simply we can say this is equal to 0. Now Q supplied, how we can calculate? So Q simply we can calculate Q will be equal to power of the heater times time, and this is equal to M times L. We need to calculate L from here. L is specific latent heat of vaporization, so simply we can write down this is power of the heater times time divided by the mass divided by M. Now power of the heater is given. This is equal to 150 watts, and the time you can read from the x-axis. So you can read time from x-axis. If you read time from x-axis, this is equal to 5.5 minutes, and you have to multiply this one with 60 because you need to convert into SI unit, means into second, and you need to divide by the mass of the substance. This is given in kg, so simply we can divide. So our final answer will be 1.1 times 10 to 6 joules per kg. Question asks us to calculate in kilojoules, so simply we can write down this will be 1.1 times 10 to 3 kilojoules per kg. So this is our final answer, 1.1 times 10 to 3. So this is final answer. For the last part, question is asking us to suggest what can be deduced from the fact that section Q on the graph is less steep than section P. So first of all, let's try to understand specific heat capacity. So specific heat capacity of the liquid we can calculate in this region, means from here to here, and the specific heat capacity of the gas we can calculate in this region. Now first of all, let's write down what is specific heat capacity. Specific heat capacity Q is equal to mc delta theta, and this is the change in temperature. But for this question it is given to us the heater has this power, so we can divide the both sides by time. So now this is the power, and here we also need to divide by time. So we can simplify this one. We can say in this case the P, this is equal to mc delta theta divided by time. Now the P is the same because we are using the same heater to heat liquid in this region and gas in this region. So P is the same, and the mass is the same. Mass of substance is also same. This is greater, it means the C is lower. But for this question is already it is given to us that section Q is less steep. Section Q is less steep. So simply we can write down here now. So this side we will discuss P and this side we will discuss Q. So for section P, delta theta over T, this one is greater because this one is steeper. So it means the C of this section, this will be lower. So you can see from here. But for the Q section, delta theta means the gradient. Actually, we have temperature on y-axis and we have time on x-axis. So that is the gradient. So that is delta theta by T. So for section Q, this is less. So it means the C of section Q is higher. Or simply we can say the specific heat capacity of gas is higher than specific heat capacity of liquid. You can also use numbers, but this is a simple way. Now let me show you how you can write down your answer. So this is how you can write down your answer if you have written this one. Or simply you can say specific heat capacity of gas is greater than specific heat capacity of liquid. You will get 1 mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from March 2021 paper 4.2. In this lesson, we will discuss how to use A is equal to minus omega square x. We will also discuss why the time period of simple pendulum does not depend on amplitude of oscillations. For part A, the defining equation of simple harmonic motion is given, means this is the key equation for simple harmonic motion, and any simple harmonic oscillator has to obey this equation. In this equation, A is the acceleration, omega is the angular frequency, and x is the displacement. Question is asking us to state the significance of minus sign, means simply what this minus sign is telling us, or why this minus sign is in front of omega. Let's try to understand this one with the help of spring mass system. Let's say we have one spring, so this is one spring and this is unstretched, and we attach one mass in front of this spring. So this one is the mass, we can say this is capital M, and spring has no mass. Our assumption is that spring has no mass, and we apply force on this one and we stretch this spring mass system to this new position. So we can say this is new position. So now you can see here this system has displacement. We displace this one by this amount. We can simply say this one is x naught. So this is the maximum displacement. So this is amplitude of this spring mass system. So when we let it go, this mass will start oscillating between these two positions. So this one is the second position. So we can say this is one and this is second. This is also called extreme positions, and this amplitude also will be equal to x naught. We are assuming that in this case there is no friction. Now we need to look at forces acting on this spring mass system. There is no friction. The surface is frictionless. So the only force acting on this mass along horizontal direction, means when it is here, when you let it go, mean this is oscillating. We are talking about when this system is oscillating, or simply you can say when this mass is oscillating. If you look at this point, the force acting on this one is the restoring force, or simply we can say this is the spring force. Now imagine that at this point this is our origin, so x here is equal to 0, and to the right we take as positive. So if it is here, so the displacement of spring mass system, when it is at this point, the displacement of this mass is x naught. This is equal to amplitude, and if we take to the right positive, so it means the displacement is positive, but the force is acting to the left, so Fs is acting to the left, so we can say the force is negative. If the force is negative, it also means that acceleration is negative, because resultant force and acceleration, this force is also the resultant force acting on mass. Resultant force and acceleration, they always have same direction. Now from here you can see that when A is negative, x is positive. If you look at this point now, when spring mass system, or simply we can say the mass is at this point, the force acting on this mass is to the right, so Fs is to the right. So we can say in this case Fs is positive. If Fs is positive, it means A is also positive, but this is on the left side, so the displacement of this mass is x naught, but this one is negative. So you can say when A is positive, x is negative, and when x is positive, A is negative. So simply we can say acceleration and displacement, they are in opposite directions at any position, or we can say at any given time. So this is the significance of negative sign. This is how you can write down your final answer. Simply you have to say that acceleration and displacement are in opposite directions. It simply means when x is positive, A is negative. When x is negative, A is positive. And this question has only one mark, and this is B mark, mean it has to be in your answer. If you write down this one, you will get this mark. For part B, it is given to us each spring is 12.0 cm centimeters when it is unstretched, and spring constant of each spring is 8 newtons per meter. When trolley is in equilibrium, the length of each spring is 18.0 centimeters. So simply we can write down, first of all, when the springs are unstretched, we can say L naught is equal to 12.0 centimeters. And when the trolley is in equilibrium, so simply we can write down, when the trolley is in equilibrium, the L of the springs, we can say L1 is equal to 18.0 centimeters. So you can see from here now, the extension in each spring will be equal to 6 centimeters because 18 minus 12. So this is very important point. We have to keep this one in our mind. Next thing, it is given to us the trolley is displaced by 4.8 centimeters to one side and then released. Means we can displace this trolley. We can imagine that it is displaced to the right, or you can imagine that this is displaced to the left. And it is also given to us, we can assume that there are no resistive forces acting on the trolley, means acting on this system. We have to show that the resultant force on the trolley at the moment it is released is equal to 0.77 newtons. So let's try to understand. First of all, in this case, I will assume that I displace this trolley to the right. So you can see this figure now. I have already drawn this one here. In this case, I displace this trolley to the right. Now the next thing you need to understand, when I displace this trolley to the right by 4.8 centimeters, the extension of this spring, so I will write down here, I'm saying this is spring 1 and the spring on the left side, this is second spring. So the extension of this spring will decrease. Before, extension of this spring was 6 centimeters, now minus 4.8. So the extension of this spring, we can write down here, delta L1, that will be equal to 18.0. This is one way of writing, otherwise simply you can find out that will be 1.2. So this is the total extension, then minus unstretched length and minus you decrease extension by 4.5 centimeters. So the extension in this spring now, that one will be equal to 1.2 centimeters. So it is still stretch. So this is still stretch, or you can say this is extension in spring 1. Spring 1 is still stretch, means it is stretched this way. So it will be pulling trolley to the right. So this is pulling trolley to the right. So this is forced by spring 1. So we can say this is F1. And now we look at spring 2 now. So spring 2 is pulled to the right. So it means extension of this one will increase. So we can write down next step. We can say the extension of spring 2, this increases. So I simply write down arrow up means increases. So now we can find out value of delta L2, means the extension in this spring. So first of all, we have this is 18.0 centimeters minus we have in this case 12. So this is the unstretched length plus we extend this one to the right, means we pull this one to the right. So we have to add 4.5 here. So this is 4.5. So this is what is given. So this is 4.8 actually. This is also 4.8. So it has to be 4.8. So this is also 4.8 because we displace this one to the right by 4.8 centimeters. So the total extension in spring 2, this will be equal to 10.8 centimeters. So that's all. Now we have extension in each spring. So when this spring is extended to the right, so this will be pulling this trolley to the left. So we can say this is F2. For this question, we need to calculate the resultant force and our answer has to be equal to 0.77 Newton. So how we can find the resultant force? So resultant force simply is equal to the net force acting on this trolley. F2 is bigger because extension is greater. So we will take to the right, means to the left we will take positive. So this force is bigger. So we will take to the left positive. To the left positive we will take. So let me clean this one to avoid any confusion. If we take to the left is positive, so this force is positive and we have to add these two forces, and force F1, this will be negative. So simply we can say in this case F2 minus F1. F2 minus F1. So how we can calculate F2? F2 simply will be equal to spring constant times extension in spring spring 2 minus k times extension in spring 1. Now the value of k, we can take simply k out because k is common. So this is delta L2 minus delta L1. And the value of k is given. So we have k is equal to 8.0 newtons per meter. So this is value of k. Delta L2 we have. Delta L2 is 10.8. This is in centimeters. We have to convert this one into meters. Minus we have extension delta L1 that is equal to 1.2 centimeters. We have to convert this one into SI units. So we multiply with 10 to negative 2. Now if we solve this one, our final answer will be 0.768 newtons. So this is the resultant force. If we write down this answer up to 2 SF, our final answer will be 0.77 newton. So this is the answer, and this is what question was asking us to show that resultant force is equal to this. I hope it is clear to you. Only the difficult part of this question is extension. So this spring is stretched, still stretched. This is also stretched. When we displace this trolley to the right, extension of this spring 1 decreases and extension of spring 2 increases. So this extension decreases, that's the reason we have subtracted 4.8, and extension of this one increases, that's the reason we have added 4.8 here. So that's all. This is what we need to understand. Very important question. For the second part, the mass of the trolley is given. This is equal to 250 gram. We need to calculate maximum acceleration, but we have calculated maximum resultant force. So simply we can say that F net is equal to A means M times A max. We have calculated already maximum value of resultant force that was equal to 0.77. Now question is asking us to calculate maximum acceleration. So simply we can say this one is equal to F net maximum. We have already calculated maximum, so we have to divide by mass. So F net maximum is 0.77 newtons and the mass is 250. So if we divide this one by 1000, we will get this is 0.25, and our final answer in this case will be 3.07. Given data has only 2 SF, so our final answer also should have 2 SF. So we can write down our final answer. This is 3.1. So 3.1 meters per second is the maximum acceleration of the trolley. For the next part, we need to use our answer in 2 to determine the time period of the subsequent oscillation. So we can simply start from A max. So we can simply write down A max. This will be equal to amplitude times omega square. We have just ignored negative sign. We are talking about magnitude, so we don't need negative sign. From here we can find out omega. So omega simply will be equal to A max means maximum acceleration divided by amplitude of oscillations, and we have to take the root of this. So simply we need to plug in values now. We have calculated A max. We will be using 3.07. The exact values we have to use, not approximated values. So that's the reason I'm using 3.07 instead of 3.1. Yeah, we have to divide by the displacement. So displacement of the oscillations means the maximum amplitude was 4.8 centimeters. So we have to multiply with 10 to negative 2 because 4.8 was given in centimeters. So we have to convert into meters. Now if we solve this one, our final answer will be 8.0. So this is 8.0 radians per second. Simply we can say it is per second. Angular frequency. So the unit of this one is per second. Omega. Now we need to understand omega. Omega is equal to 2 pi over t. We have value of omega now. We need to find out t. So simply t will be equal to 2 pi by omega. So 2 pi. So we have 2 and the value of pi is 3.142 and we need to divide by omega. Omega is 8. So our final answer in this case will be 0.78 seconds, and this is the final answer for this question. For the last part, it is given to us the experiment is repeated with an initial displacement of trolley of 2.4 centimeters. So this is new initial displacement. In the question before, the initial displacement of the trolley was 4.8 centimeters. Now simply you can see from here, this is the half of 4.8 centimeters. So this is 2.4 and this is 4.8 centimeters. Now displacement is half, means initial amplitude is half. Simply we can start from here. A is equal to minus omega square x, and from here we can find out a is directly proportional to x. So when x becomes half, it means a also becomes half. So if a becomes half, so it also means that the net force also becomes half if the mass does not change. Mass is not changing, so it means F net also decreases. That in spring mass system, we need to understand F net in spring mass system is equal to minus kx. So this is spring mass system, but F net is also equal to ma. So simply we can say this is equal to minus kx. From here we can find out a is equal to minus k over m times x. We can say this is equation 1 and this one is second. If we compare these two, we can simply find out that minus omega square x, this is equal to minus k over m times x. Or simply you can cancel this minus sign and we can write down omega squared, this is equal to k over m. Or we can say that omega is equal to root of k over m. So this is k over m. So omega is depending on k and m. So if x change, omega does not change. Omega is also equal to 2 pi over t. So from here we can find out the time period of oscillation. This will be equal to 2 pi over omega. So we can plug in value of omega. Omega is equal to root of k over m. Or simply we can say that time period is equal to 2 pi m over k. And this is how we can calculate time period of spring mass system. As time period of spring mass system is depending on mass and spring constant, so it is independent of initial displacement. So simply we will say in this case there will be no change in period of oscillation, so no change in period. So one thing we can write down. And the second we can write down is we can write down as time period as t is equal to 2 pi m over k. So time period is independent of initial displacement. So is independent of initial displacement. So that's all what we can write down for this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electric field from March 2021, Paper 4, Variant 2. In this question, we will discuss some very important concepts about electric field. And those concepts are very important to understand this topic and to answer similar type of questions in exam. For part A, we need to state a similarity between the gravitational field lines around a point mass and the electric field lines around a point charge. First of all, let's try to sketch gravitational field around a point mass. Let's say this is our point mass. Point mass means that it has no size. If we need to draw the gravitational field around this point mass, we need to draw field lines pointing towards this mass because gravitational force is always attractive. It simply means that if we place a test mass here, this mass will be attracted towards this point mass. We can draw some more gravitational field lines. So this is how we can draw the gravitational field around this point mass. So this is gravitational field. So if you look at the shape of this one, this field is radial. So this is radial field, or we can say radial field lines because the field lines are along radius. So we can say these are radial field lines. Now imagine that we have a positive point charge. In this case, if we need to draw electric field lines, we have to draw these field lines pointing away from this charge. So this is how we can draw the field lines if the charge is positive. So we can draw some more field lines. So you can see the clear shape of this electric field. So this field around this point charge, this is radial field, or we can say these lines are radial
field lines. So this is the similarity between these two fields. We can also draw for negative point charge. So if we have a negative point charge, so let's say this is our negative point charge, and these are field lines around this negative point charge. In this case, we have to draw field lines pointing towards this negative charge, because in this case, if we place a positive test charge here, force on this one will be attractive, like gravitational force. So we have to draw field, these arrows pointing towards this point charge, very similar to the gravitational field. So we have to draw arrows pointing towards point charge. So this field is also radial. So we can say this field is also radial. Or we can say the field lines are along radius, so we can say radial field lines. So if you look at similarity, you can see point charge or point mass, they have radial field lines. This is one similarity. So one similarity we can say both have radial field lines. So simply we can say radial field lines. So this is one similarity. We just need to write down one. If you write down one, you will get 1 B mark. This is. But we can also write down another one. But if you look at these fields, we can also see one thing more is similar. If you look at the distance between these lines, you see as the distance is increasing from this point mass, the gap between the lines is increasing. It means the gravitational field is getting weaker. And this is inversely proportional to r square, mean the distance from the point mass. And this field is the same. As you see, we go away from this point charge, the gap between lines is increasing. This is telling us that electric field is also inversely proportional to r square, and r is the distance from any point to the center of this charge. So this distance, this is r. So in this case, this distance is r. As r increase, field get weaker and weaker. So the second thing we can say, both obey inverse square law. So we can say inverse square law. If you want to write down relationship, you can also write down. But if you simply write down inverse square law, that's quite enough. Both obey. So these two things we need to write down, but for this question, you just need one of them. If you write down, you will get 1 mark. By looking at these fields, we can say gravitational force is always attractive. So gravitational force is always attractive. But if you look at this one, in this case, electric force is repulsive. So electric force is repulsive. But if you look at this one, electric force is attractive. So it means electric force can be repulsive, it can be attractive, but gravitational force is always attractive. For part B, it is given to us the variation with radius r of the electric field due to an isolated charged sphere in a vacuum is shown in figure 6.1. Use data from figure 6.1 to state the radius of the sphere. So first thing we need to understand, we have isolated charged sphere. So imagine that this is isolated charged sphere. If we place any charge on the surface of this sphere, that charge will not stay here. This charge will be equally distributed. For example, we have only 2 charges on the surface of this one. Those charges, they will go away from each other as much as possible, because like charges, they repel each other. So the only way where they can stay is at the surface and away from each other. If we have 4 charges, they will be distributed somewhat like this. If we have 6, let's say we have 8 charges, they will be distributed like this. Means they will stay at the surface and they will be far away from each other as much as possible. And that is only possible they stay at the surface. So if we look at, imagine that we place one positive charge at the center of the sphere. The net force on this positive charge at the center will be equal to 0. So the net force on the charge at the center center will be equal to 0 because forces due to these charges, they will cancel each other. So the net force on charge at the center of the sphere will be 0. So we will simply say charge in this case will not move. Charge inside the sphere will not move. Charge inside will not move because net force on the charge is equal to 0. So we can also say the electric field inside, as net force is 0, so electric field inside the sphere is also 0 if this is conducting sphere. So in this case we have charge sphere, that is conducting sphere. So in electrostatic equilibrium, field inside this sphere will be equal to 0. So the field inside sphere is equal to 0. We can also see this one from this figure. In this case you see electric field up to this point, electric field is equal to 0 and this point is 2.1. So it simply means that the radius of the sphere, this is equal to 2.1. So simply we can write down radius of sphere is equal to 2.1. Let's try to understand a little bit more about this one in a little bit different ways. So you can visualize this one. This question is very common in past papers. If you look at given informations, it is given to us the variation with radius r. So it means this one is the radius. So this is the first thing you need to understand. That's the reason we said radius is equal to 2.1 centimeters. We can draw this sphere as well. If I draw the sphere here, you can simply see this one is the sphere. So it is simply telling us r is the radius of the sphere. R you can simply see from here, r is the radius of sphere. So that's the reason we said r is equal to 2.1. So this is value of electric field at the surface of sphere. So we will need this value. So the electric field at surface of sphere is equal to 1.3 times 10 to 5. So we can say at surface, we will need this value for the next part. We will say at surface, electric field is equal to 1.3 times 10 to 5 volts per meter. So this is value of electric field at surface. And after this one is decreasing and this will follow inverse square law. So inside electric field of this sphere is equal to 0. So electric field here is equal to 0. For the second part, we need to calculate the charge on the sphere. On the sphere simply means that at surface of sphere. So simply we can write down. We need to calculate Q at surface. So we can also write down here. This is what we need to calculate. Q at surface. Now, if you look at this given graph, we can also sketch the sphere at this point. So this one is the sphere. What question is asking us to calculate? That is charge at surface of sphere. Means the charge on the surface of the sphere. Imagine that we have certain amount of charge at the surface of sphere. So we have this amount of charge. This is at the surface, and this is we need to calculate. This is we need to calculate. Mean this value of Q. So how we can calculate? First thing we need to understand, at the surface of the sphere, we have value of electric field. So we can say E surface we have, and E surface is equal to 1.3 times 10 to 5 volts per meter. We also understand for a point charge, means for a charged sphere or for a point charge, electric field is equal to Q over 4 pi epsilon naught times 1 over r square. In this case, we need to calculate Q. So we can rearrange this one. So in this case, Q will be equal to 4 pi epsilon naught times r square times E. Now simply we need to plug in values, and this r is the radius, means the distance from the center of the sphere, and that distance is equal to radius. So simply we need to plug in values and we can find value of Q, means the Q at surface of this sphere. So in this case, pi is constant, so simply we can say this is 4 pi. Epsilon is constant. You can get value of this one from given values of constants, and this is equal to 8. 6.85 times 10 to negative 12. Radius of sphere we have already found, that was 2.1, or you can simply read from here. This is 2.1 and this is in centimeters, so we have to convert this one into meters and the square of that, and we need to multiply with electric field. Electric field at the surface is 1.3 times 10 to 5, means this value we have is 10 to 5. Now we just need to simplify and we can find out final value of Q at surface. So up to 2SF, this is 6.4 times 10 to negative 9 coulombs. So this is value of Q. So our final answer for this question is 6.4 times 10 to negative 9 coulombs. This is how we can calculate charge at surface of sphere. For part C, we need to use the formula for the electric potential due to an isolated point charge, and we need to determine the capacitance of the sphere in P. First of all, let's try to write down electric potential due to isolated point charge. Value of V is equal to Q over 4 pi epsilon naught times 1 over R. So this is the formula for electric potential for an isolated point charge. For this question, we need to calculate capacitance. Capacitance is equal to Q over V. We need to calculate capacitance of isolated charged sphere. So we have to take value of Q at surface of sphere, and we have to take value of V at surface of sphere as well. So C is equal to Q surface over V surface. Now simply we need to plug in value of V and we need to simplify this one. V is equal to Q over 4 pi epsilon naught times R. So if we simplify this, we can say this is equal to Q over Q times 4 pi epsilon naught times R. So this Q we can cancel with this Q. So simply C is equal to 4 pi epsilon naught times R, and R is the radius of sphere. So if the radius of the sphere is greater, it means the capacitance of sphere is greater. Simply means that sphere can store more charge. Now we need to plug in values. We need to calculate value of C. C is equal to 4 pi epsilon naught times R. You also need to understand how to derive this formula. Sometimes they will simply ask you to derive this one. So the derivation of C is also important for your exam. Now simply we need to plug in values. 4 pi is constant. Epsilon naught is 8.85 times 10 to negative 12. R is the radius of sphere. So R is the radius because we are talking about charge at surface of sphere. So R is the radius. So let me redraw this here. So in this case, we are talking about charge at the surface. So R is the radius. So R is this radius. And value of R we have already found. That was equal to 2.1 centimeters. So we have to convert this one into meters. Now if we simplify this, we can get final answer for C. That will be equal to 2.34 times 10 to negative 12 in farads. So this is our final answer, 2.34 times 10 to negative 12. So this is how we can answer this question. Very common question in past papers. So you need to understand how to answer this type of problem.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetism from March 2021, paper 4, variant 2. In this question, we will discuss how to use right-hand grip rule and Fleming left-hand rule. We will also discuss about forces between two wires if current flow in same direction in two wires. So we will compare the magnitude of the force between two wires and also direction of forces between two wires.
These points are very important to understand motor effect and also to understand electromagnetism. For question number 8, it is given to us two long straight wires P and Q are parallel to each other as shown in figure 8.1, and direction of current in each wire is also given. So this is direction of current. The pattern of the magnetic field lines in plane normal to wire P due to current in the wire is also shown. For part A1, we need to draw arrows on the magnetic field lines in figure 8.1 around wire P to show direction of the field. So in this case, we have direction of current. We need to find direction of magnetic field. So we have to use right hand grip rule. So let's try to understand a little bit about right hand grip rule. When we can use this one, right hand grip rule means you have to use your right hand, and right hand can be used to find direction of magnetic field. It can be used to find direction of magnetic field, or it can be used to find direction of conventional current. So if one is given, we can find the other one. If we have direction of conventional current, we can find direction of magnetic field. If we have direction of magnetic field, we can find direction of current. So vice versa is true. Mean if this is given, for example, if this is given to us, we have direction of magnetic field, we can find direction of current. And vice versa is also true. We can go this way or we can come this way. So this is true. Now in this case, we have current. Current is given, we need to find direction of magnetic field. So simply you have to use your hand like this. So thumb is in direction of current flow. So these fingers, they are telling us direction of magnetic field. So in this case, direction of magnetic field is counterclockwise. Means this is direction of magnetic field. So this is direction of magnetic field. Counterclockwise, CCW. That's all what you need to do for this question. Let's try to understand one more point. If we look at magnetic field at this point, so magnetic field here is into the page. So magnetic field here is into the page. So anywhere here, magnetic field is also into the page. Because magnetic field here is into the page. So anywhere here, magnetic field will be into the page. And into the page, we use symbol X for that. So magnetic field here is into the page. Magnetic field here is also into the page. So we will write down here, magnetic field here is into the page, because we need this point to answer next question. For this question, simply you need to draw these arrows. For the second part, we need to determine direction of the force on wire Q due to the magnetic field from wire P. So this is our wire Q. So if we need to find force on this one, means force on Q, this will be equal to BIL. So this is BIL. But this B has to be external magnetic field. I is current in wire Q. We can say this is Q. This is L is length of Q. So we can say this magnetic field is due to P, and this is current of Q, and this is L of Q. B due to P. We have already discussed the magnetic field due to P at this point is into the page. So magnetic field here is into the page. So here magnetic field is also into the page due to wire P. Now in this wire, current is flowing up. We need to find out direction of force. So we have to use Fleming left-hand rule. To find direction of force, we have to use Fleming left-hand rule. So we will say FLHR. Fleming left-hand rule we have to use. So Fleming left-hand rule is used for current, is used for magnetic field, and is used for force. If two of them are given, third one we can find. So first of all, force. We use thumb for force, and we use index finger, means this finger, index. So let me write down index. For B we use index finger for direction of B, and middle finger we use for current. So here we have middle finger. Middle finger is used for current. So we can say this will tell us direction of force, and this will tell us direction of magnetic field, and this one will tell us direction of current if other two are given. Now simply we have to use, so in this case, for example, direction of current is up, so direction of current is up. So this is direction of current. As you can see here, direction of current is up, and magnetic field is into the page. So magnetic field is into the page. So as you can see, this finger is pointing into the plane of the page. So this is direction of force. So the force is to the left. So simply we have to write down here, force on Q is to the left. So force on Q is to the left. So this is what we have to write down for second part. But another way to understand this one is, if current flow into wires in the same direction. We have discussed this point in previous videos. If current flow into wires in the same direction, these two wires, they will attract each other. But if current flow into wires in opposite directions, these two wires, they will repel each other. Means the force on this wire will be this way, and force on this wire will be this way. So these two, they will repel. But if current flow into wires in the same direction, these two wires, they will attract. So without using Fleming left hand rule, you can find out direction of force on wire. So in this case, direction of force is to the left. Let's move on to next part. For the next part, the current in wire Q is less than current in wire P. So it simply means that IQ is less than IP. This is given to us now. We need to state and explain whether the magnitude of the force on wire P is less than, equal to, or greater than the magnitude of the force on wire Q. So first of all, let's try to understand how we can find magnitude of force on any wire. We have already discussed a little bit about force on Q. So if we talk about force on Q, we can write down here, this force is equal to BPIQ. But B is equal to, let me write down here, this is very important point. Magnetic field around any wire is equal to mu naught I divided by 2 pi r. For example, if we have here, this is wire, let's say current in this wire is I, and we want to find out magnetic field at this point, so we can use mu naught I over 2 pi r. R is the distance between wire and that point, so this one is over r. So BP we can replace with mu naught, this is current in wire P, divided by 2 pi r, and this is multiplied with IQ times LQ. So this is how we can find out magnitude of force on wire Q. But if we need to find out magnitude of force on P, we have to use magnetic field due to Q, current in P, and L of P. Now if we write down magnetic field due to Q, we will write down mu naught IQ divided by 2 pi r, and this is multiplied with IP times LP. If LP, for example, so let me write down, this point is very important. If LP is equal to LQ, if LP, this is equal to LQ. So these two equations, they are the same. Or we can simply say that, in this case, we can simply say that force over length means F over L. This is equal to mu naught I1, I will simply say I1, I2 divided by 2 pi r. So we can say, in this case, force is directly proportional to product of current. So it doesn't matter if any current is higher or lower, force on two wires will be the same, because current is proportional to product of currents in two wires. So this is the main point we need to understand. So in this case, magnitude of force on two wires will be the same, but opposite in direction. So let me show you how you can write down answer. This is how you can write down your answer. This answer you can explain using two different methods. So this is our statement. First of all, this is our statement. In our statement, we have said magnitude of forces on two wires are equal. You will get 1 mark for this one. And second one, this is your explanation. You have explained. So this one is over explanation. So this is explanation. We have said force is directly proportional to product of currents in two wires. So you will get the second one. And other way to explain this one, you can say that according to Newton's third law, forces have same magnitudes and opposite directions. So let me clean this one. Maybe you will not be able to see this part. So let me make some space for you. So second point, second way to explain this one, you can say forces are equal in magnitude according to Newton's third law and they are in opposite direction. So this is, you can also say, for explanation of this question. This question is very common in past papers, so you need to be very clear about this. Part B is about MRI, and MRI is not part of syllabus for 2022. It's not part of syllabus for 2022. This is from old syllabus, so we will not discuss this question, but I will only write down the answers for this question. If you're curious, you can go through this answer. So this is the answer for part B, but this question is not part of syllabus for 2022 and onwards, and this question is from old syllabus, so we will not discuss, but you can see the answers for this question here. Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important past paper question on electromagnetic induction from March 2021, paper 4, variant 2. In this question, we will talk about magnetic flux linkage, eddy currents, and some other important points about electromagnetic induction. And we will discuss these points by solving past paper question. For question number 9, part A, we need to define magnetic flux linkage. First of all, let's try to understand magnetic flux linkage with the help of formula. Magnetic flux linkage is simply equal to number of turns of coil times magnetic flux. But magnetic flux is equal to B times A is equal to B times A. B is magnetic flux density. So we can write on here B is magnetic flux density, B is magnetic flux density, and A is cross-sectional area. So we can say A is cross-sectional area of coil. So we can write down magnetic flux linkage is equal to N times BA. So this is how we can write down equation for magnetic flux linkage. Now let me show you how you can write down the answer for this question. This is how you can write down the answer. For the first part, we have said the product of magnetic flux means magnetic flux and the number of turns of coil. So we have defined this one. Magnetic flux linkage is equal to N times magnetic flux. In the second part, we have defined what is magnetic flux. So we have said magnetic flux is the product of the magnetic flux density normal to the plane of the coil. Very important point. You have to mention normal to the plane of the coil. Means these magnetic lines normal to the plane of the coil. So we have to consider this component of magnetic flux density. This one is the plane of the coil and normal to the plane of the coil. Very important part. So this is the plane of the coil. So the magnetic flux density normal to the plane of the coil. This part is very important, and this one has 1 mark. And the next one, cross-sectional area of the coil. So this is how you can define magnetic flux linkage. And if you look at number of turns of this coil, so this is 1 turn. This one is the second one, third one, fourth, fifth, sixth, 7, 8, 9, 10. So this coil has 10 number of turns. For part B, it is given to us a solenoid of diameter 6.0 centimeters and 540 turns is placed in a uniform magnetic magnetic field, as shown in figure 9.1. This coil has 540 turns and the diameter of this one is 6.0 centimeters. If you look at cross-sectional area of this solenoid, we can draw area normal vector. So this is area normal vector and this is B, magnetic flux density. And the angle between these two is equal to 0 degrees. So theta, simply we can say between A and B, this is equal to 0 degrees. For this question, it is also given to us the variation with time t of the magnetic flux density is shown in figure 9.2. On y-axis, we have magnetic flux density and this is in milliteslas. And on x-axis, we have time and time is in seconds. For this question, we need to calculate the maximum magnitude of the induced EMF in the solenoid. So let's try to understand how we can calculate induced EMF. Induced EMF is equal to negative d phi by dt. And this is only true if the coil has only one turn. That in this case, coil has n number of turns. So it means this is equal to rate of change of magnetic flux linkage. And magnetic flux linkage is equal to NBA cosine of theta, and theta is the angle between A and B. For this question, it is given to us angle between A and B is equal to 0 degrees. So cosine of 0 degrees is equal to 1. So simply we can write down is equal to 1. Then we can write down EMF induced. This is equal to d by dt times NBA. But for this question, n is constant, means coil has fixed number of turns and cross-sectional area of the coil is also fixed. So these two are constant, so we can take them out. So we have negative NA and this is d by dt. We need to calculate d by dt. It simply means that we need to calculate the gradient of this graph. Question is asking us when maximum value of EMF, and value of EMF is maximum when d by dt is maximum, means when this quantity is maximum, and this quantity is maximum when the gradient is maximum. So the gradient is maximum here in this part, gradient is maximum, so it means here EMF induced is maximum. So here EMF induced is maximum. So we have to calculate the gradient of this line. We can write down here maximum EMF induced. This is equal to negative number of turns we have 540 and cross-sectional area we can write down is pi r square and we have to multiply with the gradient. So d by dt is simply equal to gradient. So we can write down this is the gradient. We need to plug in values. So we have negative 540. We have pi radius is equal to 3.0 centimeters. So we can write down 3.0 centimeters. So multiply with 10 to negative 2 square of this gradient. So at this point we have this is 250 and here we have 0. So it means 0 minus 250, but this is in millitesla, so we have to multiply 10 to negative 3 divided by time. This is from 6 to 7.2, so it means the time in this case is 7.2. We can write down minus 6. We can solve this one and we can find out final answer. So the final answer in this case will be equal to 0.318, or simply we can say is equal to 0.32 volts. So this is our final answer. For part C, it is given to us we have a plate of copper and this is supported by a rod, and this copper plate is placed between poles of magnet. Then we displace this one to one side and then release it so that it oscillates. A motion sensor is used to record the displacement of X. For this question, it is also given to us a second thin copper sheet Y y replaces x. Y has the same overall dimensions as x but is cut into the shape shown in figure 9.4. The motion sensor is again used to record the displacement. In figure 9.5 shows the variation with time t of the displacement s of each copper sheet. For part C1, we need to state the name of the phenomenon, illustrated by the reduction in the amplitude of the dashed line. If you look at dashed line, so it has this much amplitude here and then it has this amplitude here, and at the beginning amplitude is this. So if we draw and connect these points, we will get exponential decay like this. We can also connect these points to get better picture of this. So if we connect these points, so this is also exponential decay. As this is exponential decay, so simply we can say in this case amplitude decreases gradually and exponentially, exponentially. So this is light damping. So simply we can say this is light damping. That's all what we need to do for this question. Simply we need to write down this is light damping. For the second part, we need to deduce which copper sheet is represented by the dashed line, and we need to explain our answer using principles of electromagnetic induction. So this one is X and this one is Y. We need to find out which copper sheet is represented by this dashed line. That is what we need to find out, and we need to explain our answer using principle of electromagnetic induction. First of all, let me show you what is happening in this case with the help of animation, and then we will come back and we will write down the answer for this question. Let's try to understand the motion of the solid plate and slotted plate inside magnetic field. Simply you need to look at motion of these two plates and you need to understand the difference between motion of these two plates, and then I will explain to you why the motion of these two plates inside same magnetic field is different, and this is what C2 is asking us, and then we will explain why the motion of these two plates is different using principles of electromagnetic induction. In this case, you can see we have a solid plate. If I move this solid plate outside of the magnetic field and then let it go, you will see after very short time this plate will stop. So we will simply say in this case the time taken by the solid plate is very short time. So we can say this time is very short time. Now if we replace this plate with slotted plate, so this one is slotted one, and leave it from the same height, you will see this will take very long time. So this slotted plates take long time, so we can write down it will take long time. So you can see from here motion of solid and slotted plate inside the uniform magnetic field is different, or we can simply say very short time simply means that energy dissipated very quickly in first case, energy dissipated quickly, so we can say energy dissipated quickly, or simply you can say in this case mechanical energy converted into electrical, and electrical finally converted into thermal energy, and time taken in this process is very short time, but for slotted plate time taken is longer. Now we will explain this one using principle of electromagnetic induction. In the animation we have seen that time taken by the solid plate was very short time. Solid plate time taken was very short time, but the time taken by the slotted plate was very long, so we can say slotted plate long time. Now we have to use this fact and we need to find out which curve is represented by the solid plate and which one is represented by the slotted plate. Now if you look at first of all at solid curve, mean this curve, the amplitude of this one is not decreasing with time, so it simply means this will take longer time to stop. Longer time to stop, it simply means that this one is slotted plate, so we can say this one is slotted plate. We can write down here this one is slotted plate. If you look at dashed line, time taken is short because its amplitude is decreasing with time. So it will take shorter time to stop, and shorter time is taken by solid plate. Solid plate. And solid plate, X is the solid plate. So we can say X is solid plate. So shorter time is taken by solid plate and longer time is taken by Y. And this one is slotted plate. Question is asking dashed line. So dashed line is representing solid plate, or we can say is representing copper sheet X. So this is 1 mark. If you write down this one, you will get 1 mark. Now we need to explain this one using principle of electromagnetic induction. So first thing we need to understand, when this plate is oscillating inside the magnetic field, so the oscillating plate will cut magnetic flux. So we can simply write down oscillating plate. This will cut magnetic flux lines. You can say cut magnetic flux lines. Or simply you can say cut magnetic flux. As magnetic flux is cut and rate of change of cutting magnetic flux, this causes induced EMF. So we can simply say in this case induced EMF is produced, mean EMF is induced in the plate. And due to induced EMF, there will be eddy currents induced, mean induced current means when the conductor is inside changing magnetic field, our conductor is cutting magnetic flux lines, current is induced, and that current we call is eddy current. So it simply means that in this case, mechanical energy of the plate will be converted into electrical energy. So this is electrical energy. Electrical energy. So it will be converted into electrical energy. And these eddy currents, they are different. They are different in solid plate and they are different in slotted plate. If surface area is large, eddy currents are large. Surface area. If the surface area is larger, it means eddy currents are larger. So eddy currents, we can say in plate X, I can say I is representing eddy currents. In X will be greater than Y because the surface area of X is greater than surface area of Y. It simply means that energy will be dissipated very quickly in solid plate, means its mechanical energy will be converted into electrical and then electrical will be converted into thermal due to eddy currents. Because conductor has also resistance, so the electrical energy will be converted into thermal energy. And that's all what we need to write down for this question. Let me show you the answer, how you can write down the answer. This is how you can write down your answer. First thing, you can say copper sheet X, as we have already written, you will get 1 mark. So you will get 1 mark for this one. Copper sheet cuts magnetic flux when it oscillates between the magnetic poles, and EMF is induced. So we have discussed EMF induced. EMF induced, it will cause eddy currents, and eddy currents in X is greater because it has greater surface area. So greater energy is lost in X as compared with Y. So the dash curve represents copper sheet. This is how you need to write down answer in a very systematic way. If you write down these points, you will get 4 marks. And total marks for this question are 4. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on AC and rectification from March 2021, Paper 4, Variant 2. In this class, we will discuss some very important concepts about alternating current and rectification. And those concepts are most frequently asked in past papers. For question number 10, it is given to us the output potential difference of an alternating power supply is represented by this. V is equal to 320 sine of 100 pi t. where V is the PD in volts and T is the time in seconds. For part A, we need to determine the root mean square PD of the power supply. So first of all, we need to write down the general equation for this. Means V as a function of time. This is equal to V naught, means the peak voltage, sine of omega t. Now we have to compare these two. If we compare these two, in this case, V naught is equal to 320 volts. And omega we can also get from here. So omega will be equal to 100 pi. So this is value of omega. We need to calculate root mean, means VRMS. So simply we can say VRMS. This is equal to VP, means the peak value of voltage, potential difference, divided by root of 2. Peak value is given to us. This is equal to 320 and this is divided by root of 2. So if we solve this one, our final answer will be 226. So the final answer will be 230 volts up to 2 SF. Because the given data 320, this has 2 SF, so the final answer we can also write up to 2 SF. And this question has only 1 mark, answer mark. If your answer is right, you will get this mark. Let's move on to part B. For part B, we need to determine the time period of the output. What value of omega we have? Omega is equal to 100 pi. And omega is also equal to 2 pi over t. Means this is the formula to calculate omega. We need to find value of t. So we can simply say t will be equal to 2 pi over omega. Now simply we need to plug in value of omega. Omega is equal to 100 pi. So we can cancel this pi with this pi. We left with 1 by 50, or simply we can say this is equal to 0.02 seconds. So this is our final answer. This question has 2 marks. The 1 mark you will get if you have written omega is equal to 100 pi. So this is 1 mark, you will get C mark. And the second mark is answer mark. If you have got the right answer, you will get second. For part C, it is given to us the power supply is connected to resistor capital R and a diode in the circuit shown in figure 10.1 as it is given in this figure. For part C1, we need to state the name of the type of rectification produced by the diode in figure 10.1. So first of all, we will sketch this, means V against time if there was no diode in this circuit. So we will sketch how V will change with time across resistor if there was no diode. So this will follow sinusoidal curve somewhat like this. So we will just draw 2 cycles. So this will follow sinusoidal curve somewhat like this. So this is when there is no diode in this circuit. But if there is diode, then how current will flow, means how voltage will change. First of all, imagine that if this terminal is positive, this is negative, so current will flow like this. So this is connected in forward biased, so means current can flow. So this is connected in forward biased, so current can flow in the circuit. So there will be potential difference across this resistor. After half cycle, when this become negative and this become positive, so current will flow like this. So if you look at this point, now this diode, this is connected in reverse bias. So it means that half of the cycle current cannot pass through this circuit. Means current will be blocked due to this diode. So first half current will flow, but in the second half there will be no current flow. Means there will be current will be blocked. So we will see this curve. We will see this curve. So in this case we will see this curve instead of sine curve or sinusoidal. And this is half wave rectification. Means only half of the cycle current can flow through this resistor, and half of the cycle current is blocked by this diode. So this is half wave rectification. So simply we can say this is half wave rectification. So this is half wave rectification, and let me show you the final curve how it will look like. So this is how the final curve will look like. So simply we have to write down this is half wave rectification. So type of rectification, this is half wave rectification. This is half wave rectification. We also have full wave rectification. This question has only 1 mark. So if you have written this one, you get 1 mark. For the second part on figure 10.2, we need to sketch the variation with time t of the PD VR across capital R from time t is equal to 0 to t is equal to 40 milliseconds. But for this question, we have value of peak voltage across resistor. Peak value is equal to 320 volts. We have also calculated time period that was equal to 0.02 seconds. We can convert this one into milliseconds because here we have unit of time that is in milliseconds. So simply we have to divide this one by 100 and we need to multiply by 1000. So we can get answer in millisecond. So the time period in milliseconds is equal to 20. It means that in 40 milliseconds we have 2 cycles, or we can say after every 10 milliseconds there is 1 half cycle. So here we have half cycles. First of all, let's try to sketch the sine curve, means sinusoidal curve. Then we will sketch half wave rectification curve. As value of peak voltage is equal to 320, so we can mark the peak value. In 1 half cycle we will have 1 peak value. This is 300, so here we will have 320. So we can mark 320 halfway between 0 and 10. So here we will have first peak value, and the second peak value we will have somewhere here. So this is, and the third one we can also mark, that one will be here. So this is the third peak value, and the fourth peak value we will have here. So here we will have fourth peak value. First of all, we will sketch sine curve only. So this is how we can sketch the first sine curve in the first half cycle, and in the second half cycle this is how we can sketch. So this is in the second half cycle. In the third half cycle, this is how we can sketch. This is not the final answer. This is just sine curve. And in the fourth cycle, this is how we can sketch. But this is when there is no diode in the circuit. But in this question, there is a diode that is connected in the circuit. So it simply means that this lower half, there will be no current passing through the resistor. So simply we can clean this one. There will be no current passing through the resistor, and in this half also there will be no current. So the final shape of the curve, we will see this one. So this will be final shape of the curve, and this is half wave rectification. This is how we need to sketch. If we sketch this one, we will get 30 marks. So the peak value has to be correct, time period has to be correct, and the shape of the curve also has to be correct. So you will get 30 marks. For the last part on figure 10.1, we need to draw the symbol for a component that may be connected to produce smoothing of VR. So first thing we need to understand what kind of component we need to connect. We need to connect capacitor in this case, capacitor, because capacitor can be used to store energy. So we need to connect capacitor across this resistor. So this is how we need to connect capacitor. This question has only 1 mark. If you have drawn capacitor in parallel with this resistor, you will get 1 mark, and that is B mark. Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on medical imaging from March 2021 paper 4 variant 2. In this question, we will discuss some very important points about X-rays. If you're struggling with X-rays and you're always stuck with questions on this topic, then watch this video carefully, and after watching this video carefully, you will be able to handle questions on X-rays with confidence. For question number 11, part A, it is given to us electrons are accelerated through a potential difference of 15 kilovolts. The electrons collide with a metal target and a spectrum of X-rays is produced. For part A1, we need to explain why a continuous spectrum of energies of X-ray photons is produced. First of all, let's try to understand production of X-rays. So I will write on here how X-rays are produced. Production of X-rays. In order to produce X-rays, first of all, we need to emit electrons. So the first step is electrons emission. We need electrons. So simply we can say the step one is electrons emission. And these electrons, they are emitted by thermionic emission. So we can write down these electrons are emitted by thermionic emission. Thermionic emission means that cathode is heated. When cathode is heated, electrons are emitted. You can see here, in this case, we have cathode filament. When we heat up this one, by applying potential difference across the heater, electrons are emitted. So that is called thermionic emission. Emission due to heat. So thermionic emission simply means that emission of electrons due to heat, or by heat we can say. Emission of electrons due to heat. This is called thermionic emission. And the second step, these electrons means the electrons emitted due to thermionic emission, those electrons are accelerated by potential difference. And so electrons are accelerated. So those electrons, we accelerate them by applying potential difference. So this is the potential difference you can see here between these two terminals. So we have 0 volts here and we have 100 kilovolts here. So due to this potential difference, electrons will be accelerated. Means electrons, they will gain kinetic energy. Accelerated electrons mean electrons are accelerated by PD, potential difference. So this is our cathode and this one is anode. So electrons are accelerated. When these electrons are accelerated, they gain kinetic energy. Means electrical energy become kinetic energy of electrons. So gain kinetic energy. And when these electrons, they hit the metal target, metal target. When they hit metal target, metal we use is tungsten. So the metal used for X-rays is tungsten. So this is our metal target. You can see this is. And this is made of tungsten. So this is metal target and this one is made of tungsten. And this anode is rotating because if electron is at one point all the time, temperature will be very high. So may this anode will melt. So one of the reason we use tungsten metal is it has high melting point. Then also we cool this one by circulating water here or any other fluid. So this anode is rotating. How we cool this one? By water and by rotating. So electrons don't hit one point all the time. As these electrons, they hit metal target, electrons decelerate. So we can say electrons decelerate. Decelerate means they lose kinetic energy. They lose Ke. And this lost Ke become energy of photon. So this become energy of X-ray photon. So this become energy of X-ray photon. And the energy of X-ray photon is equal to delta Ke. It simply means that this is equal to initial kinetic energy of electron minus final kinetic energy of electron. The difference between kinetic energies of electrons become energy of X-ray photon. So this is what you need to understand about production of X-rays. So this is how X-ray photons are produced. Let's try to understand this one with the help of one simple figure. I have already drawn for you here, so I will clean this part a little bit and I will explain you what is happening here. In this case, you can see we have incident electron. So this one is incident electron. It has certain amount of kinetic energy. So it has certain amount of kinetic energy. So incident electron, it has energy EKI. So we can say it has energy EKI. And when it approaches closer to the tungsten atom, this electron will decelerate because there is an attraction between electron and nucleus. So this will decelerate. So when this will decelerate, it will lose kinetic energy, and that energy become energy of X-ray photon. So after this one, the energy of electron has decreased. So this one is the final kinetic energy of electron. So the energy of X-ray photon, we can say energy of photon, this is equal to change in kinetic energy of electron, or simply we can say this is Ke initial minus Ke final. That's all what we need to understand about production of X-rays. And different electrons, they decelerate by different amounts. For example, if one electron, for example, is passing through this point, means is far away from the nucleus, so this one may decelerate by a little amount. So the photon, X-ray photon produced due to deceleration of this electron will have less energy because it will lose less amount of kinetic energy. Different X-ray photon, they have different amount of energy because they decelerate by different amounts. That's all what we need to understand about production of X-rays. I hope that it is clear to you. Now let me show you the answer, how you can write down a proper answer. This is how you can write down a proper answer. In your answer, you have to mention as the incident electrons pass close to the nucleus of an atom, electrons will decelerate. If you write down the electrons will decelerate, you will get 1 mark, and this one is B mark. And they decelerate by different amounts. So they have range of deceleration. So you will get the second B mark. Excess energy is given off as X-rays. So X-ray photons will have continuous range of wavelengths. And continuous range, this depends on amount of deceleration. So if you write down this one, amount of deceleration, you will get third B mark. Amount of deceleration, you will get third mark. So this is how marks will be awarded for this part. For the second part, we need to calculate the wavelength of the highest energy X-ray photon produced. In the last part, we have already discussed X-ray photons are produced with different amount of energies. And energy of X-ray photon depends on amount of deceleration of electrons. In X-ray production, electrons are decelerated by different amounts. They have range of decelerations. And X-ray photons, they have range of energies. So let's try to understand energy of single photon again. Energy of photon, single photon means X-ray photon produced is equal to change in kinetic energy of electron. Or we can simply say this is equal to loss in kinetic energy of electron. So we are using symbol small e for electron. And other way to write this one is we can say this is equal to kinetic energy, means the initial kinetic energy of electron minus final kinetic energy of electron. We need maximum energy. We want to give maximum energy to photon. So E of photon, when this will be maximum. So E of photon, this will be maximum when Ke final, this is equal to 0. So energy of the photon is maximum when Ke final is equal to 0. Means electron just simply stop. So in this case, we can say energy of photon, here I will be writing here, maximum energy of photon. Photon energy maximum. This is equal to kinetic energy, initial kinetic energy of electron. So this is equal to initial kinetic energy of electron. And initial kinetic energy of electron is equal to work done by PD. So this is equal to work done by potential difference, or we can simply say electrical energy supplied. So we can also write down this is equal to electrical energy supplied by PD. Electrical energy supplied. So this is electrical energy supplied to accelerate electrons. Now simply we can write down energy of photon. This is equal to hc over lambda, and work done by potential difference, this is equal to q times delta v. So this is q times delta v. We need to calculate lambda. So this is lambda minimum value. Lambda min means the lambda is minimum, it means energy of photon is maximum. So this is minimum value of lambda, and this minimum value of lambda later we will discuss. This is also called cut-off value. So cut-off value. So this is also called cut-off value. You need to calculate lambda. So in this case we can simply write down hc. This is equal to lambda min minimum times q times delta v. Q is the charge on electron. We need lambda minimum will be equal to hc over q times delta v. Delta v is the potential difference. H is a Planck's constant, so we can write on its value. You can also get this one from the data list, and this is equal to 10 to negative 34. C is a constant, 3 times 10 to 8. Value of this one is also given, and we have Q is the charge on single electron, means elementary charge. This is 10 to negative 19 coulombs, and we have potential difference which is given to us, that is equal to 15 kilovolts. So we have to multiply with 1000. Now if we simplify this one, our answer is going to be 8.29 times 10 to negative 11. But in our data we have least number of SF2, so it's better to write down our answer up to 2SF. So we can say our final answer is 8.3 times 10 to negative 11. So this is final answer. This is how you need to calculate. It's simply kinetic energy final zero, means electron just stop. So electron just stop. So electron just stop. Or we can simply say, in this case, electron is like this. This is the nucleus. This is electron. So this electron is coming. It has certain kinetic energy. When it reaches this point, it just stop here. So all the energy of this electron will be converted into X-ray photon. Let's try to understand some more important points about production of X-rays. Curve 1, and this one is the second curve. This curve is produced, means these X-rays are produced when we use voltage V1. Then this curve is produced when we use potential difference V2. In question they can ask you which one is greater. So if you look at these values, we can say we have here lambda min. So we have one value of lambda min. We can say this is lambda min 2, and this one is lambda min 1. So lambda min 2 is less than lambda min 1. It simply means that V2 is greater than V1. We can also say the energy of photon, energy of second photon, mean energy of photon in second curve is greater than energy of photon produced by V1. So photon 1, energy of photon. So this photon has high energy, this photon has low energy, because the potential difference here is greater than this one. We also need to understand lambda min. This lambda, it has a special name. I have already explained, but let me highlight this point again. Lambda min is also called cut-off value. So we can say this is cut-off wavelength. So lambda min. Sometimes in exam they can simply ask you to calculate cut-off wavelength. If you're not clear with this term, maybe you will find difficult to understand and difficult to answer. And so we can see these actually, this continuous curve, these radiations are called braking radiations, means they are produced when electrons are stopped. We call them braking X-rays, or we can say braking radiations. Braking X-rays mean this continuous curve, and these are produced. So this one you can see continuous curve, and this curve is representing braking axis, but you can see some spikes here. So these spikes are produced if coming electrons hit electrons in the target. Let's say hit this electron. If this electron is removed, then electron from the higher energy level will come to fill this empty space. So when this electron will jump from high energy level to lower energy level, this electron will release energy in form of photons. When electrons jumps from high energy level to lower energy level, they release energy in form of X-ray photons. So they release X-ray photon. That's the reason we see these spikes. And these spikes, they represent characteristics X-rays. Characteristics X-rays. So it's important to understand how characteristics X-rays are produced. So this is how they are produced. So when coming electron, they hit electrons in the metal target, they remove electron from the atom. So the electron from higher energy level, they will jump downwards to fill that gap. And when they jump from high energy level to lower energy level, they will release energy in form of X-rays. In form of X-ray photon. For part, the graph is given between ln I over I naught and X. First of all, let's try to write down the equation for this graph. In this case, we can simply write down I is equal to I naught e to the power of negative mu x. This is the standard equation we have. Now, if we rearrange this one, we can write down I over I naught. This will be equal to e to the power of negative mu x. If we take ln on both sides, we can say I over I naught. This is equal to ln of e to the power of negative mu x. And this one we can write down negative mu x times ln e. And ln e is equal to 1. Value of ln e is equal to 1. So we can simplify. We can write down ln of I over I naught. This is equal to negative mu x. But now if we compare this one with straight line equation, means y is equal to mx. So in this case, gradient is equal to negative mu. And this is the point we need. And we will answer next question. So in this case, gradient of this graph is equal to negative mu. Very important point. We will need this one for next question. Let's move on to question. For part B1, we need to determine the linear attenuation coefficient mu for this beam of X-rays in the tissue. Means we need to find out value of mu. But we have already discussed that gradient of this graph is equal to negative mu. Or simply we can say mu is equal to negative of gradient. Now simply we need to find out gradient. If we take 2 points, we take this 1 point and this point, we can calculate value of gradient. So in this case, the gradient is negative because y is negative. So here we have negative 2.28 minus 0 divided by x is positive because this is x, this is positive. We have 11 minus 0 here. And now if we simplify this negative will be cancelled with negative. So we left with 2.28 divided by 11. So our final answer is going to be 0.207 per centimeters because 11, this has unit in centimeters. So our answer is per centimeters. We can write down this one up to 2SF. So answer will be 0.21 per centimeters. So our final answer is 0.21 per centimeter. For the second part, we need to determine the thickness of tissue that the X-ray beam must pass through so that intensity of the beam is reduced to 5% of its initial value. Let's try to understand what question is asking us. Imagine that we have this tissue. So this is tissue. Question is simply asking us, we need to find out the thickness of this tissue so that intensity of X-ray beam become 5%. Imagine that this is intensity. We have on y-axis and and we have x, this is thickness on x-axis. We need to find out when intensity I naught, let's say the initial intensity of x-rays is I naught, when they pass through the body, the intensity will decrease. We need to find out when the intensity become 5%. That value of x we need to find out. I mean, this value of x we need to find out. Let's say this is x1. We need to find out value of x1. And this intensity become 5%, means 0.05 times I naught. And this is equal to 5%. Let's try to find out value of x1. But we have already discussed that ln of I over I naught, this is equal to negative mu times x. In this case, we said x is equal to x1, so we will use x1 here. But value of I over I naught is given to us. It is given to us reduced to intensity reduced to 5%. It simply means that I over I naught, this is equal to 5 over 100 is equal to 5 over 100. Now we can simply replace I over I naught with 5 over 100, or simply we can say this is equal to 0.05 I naught. Now simply we need to plug in values, so we can say ln of 0.05. So we can delete actually this I naught from here. So this I naught here. We are writing I over I naught. So I over I naught is equal to 0.05. And this is equal to negative mu, but value of mu we have calculated. That was equal to 0.207 times x1. From here we can calculate value of x1. x1 will be equal to 14.7 centimeters, because this is in centimeters. So this is our final answer. This is how you can calculate value of thickness. Now let me highlight one point. Here we have 2. If it was by, then I over I naught has to be equal to 95 by 100. Reduced by 5% mean 95% is remaining. So we can say 95% is remaining. So you need to understand in the question, is it reduced to or is it reduced by? So you need to be clear about this. That's all what you need to understand about this question. I try to explain you some very important points about X-rays. I hope those points are clear to you. If you have any questions, just leave your questions in comment section and I will be answering as soon as possible.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on nuclear physics from March 2021, paper 4, variant 2. In this question, we will discuss what is meant by spontaneous and random nature of decay, how to calculate decay constant, and some other questions about nuclear physics. For part A, we need to state what is meant by spontaneous decay and what is meant by random decay. And this question has 2 marks. First of all, we will only focus on what is meant by spontaneous decay. Spontaneous decay simply means that the radioactive decay does not depend on external factors such as temperature and pressure. For example, if we have nucleus, let's say this is one radioactive nucleus. By changing temperature or by changing pressure or other factors, we cannot increase the rate of decay or we cannot decrease the rate of decay because it is independent of external factors. When the time will come, it will just simply decay. So its decay is independent of external factors. So that's the reason radioactive decay is spontaneous in nature. Simply you can mention radioactive decay is independent of external factors such as temperature, pressure, and also neighboring nuclei. So let's say we have another nucleus here, another nucleus here. So decay of this nucleus, let's say we focus on this one. The decay of this nucleus does not depend on temperature, does not depend on pressure, and also it does not depend on these neighboring nuclei where it is located. So it also does not depend on that. So that's the reason we call radioactive decay is spontaneous in nature. It doesn't care about external factors, simply we can say. Now let's move on to next one. What is meant by random decay? So that random decay simply means that if we focus on this nucleus, for example, in this sample, we just focus on this nucleus. Random decay simply means that we cannot predict when this nucleus will decay, and also we cannot predict which nucleus will decay. So that is meant by random decay. First of all, let's try to understand what is random decay. So with the help of this animation, so you can see, if I look at this one, you can see half of these nuclei, means after one half-life, half of these nuclei decay, but you cannot say which nucleus will decay next. So this is telling you this is random decay. And also we cannot tell the time when one particular nucleus will decay. So let's look at next one, means after next half-life, half of nuclei will decay, but we cannot say which nucleus will decay. So this is after next half-life, and this is again after next half-life. Half of them decay, but we cannot say which nucleus will decay and when any particular nucleus will decay. So this is what is meant by random decay. I hope it is clear to you now. And the probability of decay of any nucleus per unit time is the same. For example, the probability of dying, means how many people die on this planet. There is a certain probability, and that probability is the same for every person on this planet. So that is also true for these radioactive nuclei. Now let me explain to you how you can write down the answer. So this is how you can write down the answer. So this is a kind of proper answer. If you mention these points, you will get full marks. So it is not possible to predict when an individual nucleus, means if you focus on this nucleus, you cannot say when this one will decay. And every nuclei has constant probability of decay per unit time interval. So they have the constant probability of decay per unit time, that what we call is the lambda, constant probability of decay per unit time. So this is called decay constant, lambda. Lambda is the same for every nuclei. So this is decay constant. So this is how you need to write down your answer. For part B, activity of a sample is given, and activity of the sample is 5.2 megabecquerel, and the mass of the sample is also given. So first of all, let's write down what is mass of the sample. Mass of the sample is 1.0 times 10 to negative 9 kgs, and activity of the sample is also given. So simply we can say A is given, this is equal to 5.2 megabq. So simply we can say this is 5.2 times 10 to 6 bq. Bq is unit of activity becquerel, and 1 becquerel is equal to 1 decay per second. Now we also need to understand what is the mass of this nucleus. So the mass of nucleus we can say is small m. Mass of nucleus is 90 U. So the mass of nucleus is equal to 90 U because the mass number of this one is 90. Now we have to convert this one into kgs. So we have to multiply with 1.66 times 10 to negative 27 kgs, because 1 U is equal to 1.66 times 10 to negative 27 kg. And this is given in data. You can find the value of U on second page of this paper. Now question is asking us to calculate decay constant, means we need to calculate lambda. In order to calculate lambda, we need to find the value of A, and also we need the number of nuclei n, but A already we have. Now we need to find out n. So how we can find out n? So this is difficult part in this question. In order to find the number of nuclei, the total mass of the sample we have, so simply we can divide the total mass of the sample by the mass of one nucleus. So the total mass of the sample in this case is 1.0 times 10 to negative 9 kgs divided by mass of one nucleus. And mass of one nucleus is 90 U, 90 AMU you can also say. So here we have to write down mass of one nucleus. Now if we solve this one, we do this calculation, our final answer will be 6.69 times 10 to 15. So this is the number of nuclei we have in this sample, and we need to calculate lambda. So simply we can divide activity of this sample is given, that is 5.2 times 10 to 6. Now if we divide this one by number of nuclei, we can find out lambda, means decay constant we can find out. So simply we have to divide by number of nuclei, and our final answer in this case will be 7.77 times 10 to negative 10 per second, means this is per second. The unit of decay constant is per second. So we can write down our answer up to 2SF. Simply we can say this is 7.8 times 10 to negative 10 per second. So this is our final answer. For second part, it is given to us the activity of the sample after a time of 1/2 lives is found to be greater than the expected 2.6 mega BQ. Suggest a possible reason for this, and this question has only 1 mark. First of all, let's try to understand what question is telling us. In the question, it is given to us that the initial activity of the sample was 5.2 mega BQ. So this is mega BQ, and after 1/2 life, it has to decrease to half, means the activity should be 2.6 mega BQ. So simply we can say after 1/2 life, this is what we are expecting. After 1/2 life, activity should be half. But according to our observation, the observed activity, so we can say observed. So this is, we can say observed activity. This is greater than expected. So simply we can say it is greater than expected. Question is asking us to explain why it's like this. Observed activity, this is greater than expected. There can be two reasons. The first reason can be the daughter products are radioactive. So one reason can be daughter products are radioactive, or we can say daughter products are unstable. So this can be one reason. And the second reason can be due to background radiation. The second reason can be background radiation. So that's the reason the observed activity is greater than expected one. So these are two possible reasons. So you can write any one of them and you will get 1 mark. I hope it is clear. So let me show you how to write down the answer. This is how you can write down answer. So there are 2 points. You can mention one of them. You can say the daughter products of nucleus are unstable, or you can say it's due to background radiations.